Oh, thank you for coming. Um, I'm with Supermicro here, Yaming Wang. Um, I want to share a bit about edge computing and AI today at our partner Rakuten Cloud booth. First of all, there are many vertical markets we have seen the AI applications. For example, the Gen AI is very common already. People using the prompt for all kinds of internal inquiries of the knowledge base, and also for even customer interactions as well. And agentic AI is requires a bit more programming to have the program running on the servers or some end devices itself. And Omniverse is, we have seen digital twins and many industrial use cases as well. So what we have seen, for example, in the industrial vertical, in the factory where there's a lot of actions happening, some called the physical AI, means you could have the inspections for the production line. A lot of them based on camera, video-based technology to do security checks or monitoring quality inspections as well. Would require the smaller boxes sitting in there with some smaller GPUs. Sometimes you don't even need GPUs, right? Just the CPU would be enough to run those applications. And also collecting data. The data, in a way, will be transferred back to a data center or sometimes cloud. We call the data foundry as a general term, where the data will be used for training the models, right? Here you would need much bigger machines, bigger servers with today we have seen a lot of our customers, they started with H100, H200, move on to Blackwell, and there's the Blackwell RTX Pro based different options customers start to use to train their models as well. And after that, the model will be deployed to the edge, where the edge will use the model and start to utilize tokens to do the inferencing on the edge side as well. And so there are two segments we have seen. One is kind of the enterprise AI servers, where you do a large batch of processing. There's a lot of data, so that's where you would require higher density CPUs and GPUs, a lot of more compute involved as well, and also high-speed networking from the traditional south and north and south kind of networking to a lot of east and west, because you would require the cluster to work together with those billions of parameter kind of large language models, right? And also multi-tenant. But then when you start to deploy to the on-premise, to the edge AI servers, there's going to be a lot of standalone deployment, and it will not require those kind of networking. But one thing is latency, right? It would require a lot of real-time processing. So low latency is quite important in those kind of edge settings. And there's third-party add-ons. In addition to the, we have seen a lot of the GPU cards from NVIDIA. There's other options out there as well to be able to offer the particular solutions to those applications. Also on the edge, there's environmental constraints. Sometimes you do not even have the data center setting, so extended temperature would be required as well, and also would require a smaller footprint in those kind of settings as well. And another thing is it's pretty fragmented. If you look across different industries, from factory to smart cities or to healthcare, they all have different environment, different regulations. So it's really, you cannot have one solution fit it all. It's kind of back to the old IoT kind of applications. It's kind of a very siloed. We have to purposely have the solution providers that have been serving in that particular vertical market to work with them together. Here I want to show you a use case. This is a real customer use case, a digital concierge. We actually showed this at the several conferences already with our partners. Last time we showed this was at GTC back in, last month. So in this particular scenario, you have a big screen, you have a avatar, and as the concierge, right, front desk person that's going to be welcoming a guest, and the guest would use your audio to trigger, you ask questions, the prompt will go into the system, and once it goes into the system, and this, we have a server there with kind of a lower amount of GPU capabilities to be able to process the incoming audio and video and doing visual analysis as well, and then start to use the rack running on another server with storage, be able to get the existing, especially searching the vector database to get the information out, and also running large language model to compile the response based on what we fetched out of the database, and then coming back into the avatar controller and then showing the answer back to the user as well. So overall, it will require a couple of servers to do the front end avatar processing and video compilation as well, and then another one running the rack at the back end, and using switches and them together. On the front as well, there's also a fanless box that's able to support the front camera and also the front screen running as well. So the benefit of this setup would be there's going to be a real-time text generation. We can cut the low latency on this one, and also there's a pretty small amount of storage for the rack as well, and it can deploy it on premise. We have shown this. We have a partner today. They actually have some live deployment with the retail stores. Some of the retail stores deploy them. You probably would recognize they have a human-sized avatar sitting in front of the retail store. Once you go in, you can ask the avatar questions and they will respond in real time. Just a quick shout out to our partner. Used to be called Robin.io. It's part of the Rakuten Cloud native storage, running out of GTC at Google, and we're a close partner with Rakuten. Work together to provide you the solutions to the Edge AI. So it's just a quick presentation on Edge AI. I want to stop here, see whether there's any questions from the audience. If not, thank you all.